Hello viewers and welcome back to our final maths class. Few days ago we started with calculus and then we have done a couple of subtopics under calculus which include the limits of functions, differentiations, limits involving infinity, and then a whole lot. Okay, so if you are new to my page or if this is the first time that you are watching my video, you can visit the other previous videos to watch till you get here, so you will get yourself acquainted with the topics that we are treating. Now today we are going to look at differentiation of a product. Okay, and differentiation of a product comes when you have an expression which you cannot easily multiply or divide them in separate terms. Okay, so we know that sometimes when the functions are given to you, they are very difficult to differentiate unless you divide them or you multiply them into separate terms before you can be able to differentiate. So if it is given to you in that way and then you cannot do the division or multiplication to separate terms, we use the product or differentiation of a product to do that. Okay, and how is that one done? If you have y to be equal to au, where a is a constant, we know that the dy dx of this expression will be a du dx. Okay, so the constant, then you differentiate what? The function. Okay, so u is in function of what? Is a function of x. Okay, so u is a function of x, so you differentiate the u, then this is what you will obtain. Okay, an example is if you have y to be equal to 15x to the power 3. Okay, so when you differentiate this, you will be obtaining dy dx to be equal to what? Sorry, this one is 5 this. Okay, so, or if it is 15, we will be obtaining what? 45x to the power what? 2. Okay, so this is a short example on this which I want you to get the explanation. Okay, now we move on to the next thing that we will look under the product. Okay, so if you have also y to be equal to uv, all right, where u and v are both functions of x. All right, so u and v, they are all functions, they are all what? Functions of x. Now in order to use the product rule to differentiate this is the formula that you will be using. Dy dx will be equal to, now you keep one of the variables, okay, which is what? Maybe v, you keep v, then you differentiate u because it is dx because it is in a function of what? X. All right, plus, then having kept v in the first place, then second one you keep u, then you differentiate v. All right, so this is how or this is the formula that we use when you are dealing with what? Product rule. Okay, so if a function is given to you or an expression given to you, y to be equal to uv, where u and v are both in the function of x, all you need to do is to keep one of the variables. Okay, keep one of the functions, which is say u first. All right, then you differentiate when you keep v, you differentiate u. All right, plus you keep u, then you differentiate v. So this is a simple formula that you have to use when you are dealing with that. So now let's look at these two examples here, and then we look at how we can apply the rules on the board. So now we have these examples on the board, these two examples. Okay, that is what we are going to use to illustrate the product rule of differentiation. Now the question says we should find dy dx if y is equal to 3x squared plus 1 times 5x minus 8. So let's look at the solution. Now with the first one, we know that the formula is dy dx will give us v du dx plus u dv dx. So the first thing that you have to do is to let v and u be each of the expressions. Okay, so the first term will be, so we will let v be equal to 3x squared plus 1. All right, Now if v is 3x squared plus 1, we will differentiate v first. So the v du will be equal to what? Will be equal to 6x, okay, and this constant will be what? 0. And then when we also let u to be equal to, when we let u to be equal to 5x minus 8, now du dx will be equal to what? Just 5, okay? So this will give you 5 and this will give you what? 0. All right, so now substituting them, all the variable or all the variables here, substituting their values into the formula that we wrote, we will be obtaining dy dx, or we'll be getting dy dx to be v, okay, v first. So what we do, make v is equal to 3x squared plus 1, then bracket close, times du dx. What did we get for du dx? 6x. So 6x. Now plus u. What did we get for u? U is 5x minus 8, then times dv dx. What did you get for dv dx? So dv dx is what? 6x. 6x. So over here du dx is supposed to be what? 5, okay? So it is 5. Sorry, I went and wrote the dv dx. So it's supposed to be what? Du dx over here, okay? So now expanding the brackets or simplifying them, you'll be obtaining 5 times this will give you 15x squared plus 5, then plus 6x times this, we have what? 6 times 5, we have 30x squared minus 6x times minus what? 8, you have minus 48x. So let's see if there is a way of simplifying them. So this will be equal to 15x squared here, we have what? 30x squared here, so we have 45x squared, then minus 48x plus 5, okay? So this will be the simple way of what? Differentiating this, all right? So with the second question, it says that we should find dy dx if y is equal to 2x minus 1 times 3x plus 2, okay? So the first thing that we have to do is to let v to be equal to what? 2x minus 1, and then u to be equal to 3x plus 2, okay? So now when we differentiate v, we'll have the v dx to be equal to just 2, all right? And then when we differentiate u, we'll have the u dx to also be equal to just 3, all right? So now substituting these values into the formula, we have dy dx to be equal to now v. What is our v here? We made 2x minus 1 to be our v, so 2x minus 1 to be our v times du dx. Du dx is equal to what? 3. Then plus u is 3x plus 2 times dv dx, which is what? 2. All right, so now when we multiply them through the then the constant by the bracket, we have 3 times 2 is we have 6x minus 3 plus 6x again plus what? 4. All right, so simplifying them, we'll be obtaining 6x here, 6x here, so we have what? 12x, the minus 3 here plus 4 here, we have what? Plus 1. And this will be the simple way of what? Expressing this using the product rule, okay? So what did I do? The first thing that you do is to quote your formula, then you let the various variables to be each of what? The expressions, okay? Then you differentiate each of the expressions. So you differentiate v, you have the v the x, which is what? 2. When you differentiate u, you have what? The u ds, which is what? Just 3. Then you substitute these values into the question or into the formula. So when you substitute them into the formula, you express them, you expand the bracket. This is what you'll be having. Then you simplify them. We're going to look at the simple way of expressing this or finding the differential coefficient or the derivative of these expressions, which we are supposed to use the product rule, okay? So aside using the normal way of the product rule to solve this, there is a simple way, and then I'm tackling this simple way, or I'm showing you this simple way because in case you meet this in an objective test instead of in a theory, you meet them in an objective test and you want to move ahead, okay? You want to move ahead and you want to beat time. How do you solve this? All right, so the first thing that you have to do is to just write your dy dx, okay? And indicate your equal sign. All right, now all you need to do is to write the first function, okay, which is here 3x squared plus 1. All right, now you have kept that one, then you differentiate the second function. Okay, when you differentiate the second function, the result that you will have, you use it to multiply what this one. So with the second function, when you differentiate it, you have 5. So use it to multiply it with the first function. So you keep the first function, then you differentiate the second function. The result, use it to multiply the first function. Now you bring your additional sign, which is plus. All right. Then in the first scenario, we kept the first function, right? Here we keep the second function. Then we differentiate what? The first function, which is this one. So when you differentiate this, you have what? 6x. Okay. So here I will divide the x. You expand the bracket, you have here to what? 30x squared plus 5. Now here plus 30x squared again here, okay? So here will be 15, sorry, not 30. So 15. So here, so 30x squared, then here will be what? Minus 48x. All right. So now when you simplify them, the y/dx will be equal to 15x squared here. We have 30x squared here. So we have what? 45x squared minus 48x, then plus what? 5. So you see, we've obtained the same result that we obtained when we use the formula to solve it. Okay, so this is just 1, 2, 3 steps instead of going about 6, 7 steps to get the answer. This is just 1, 2, 3 steps. So if you are using the product rule and then you want to work ahead time, or you want to finish in time, or time is against you, you can use this simple way to solve it, not in theory but in objectives. Okay, but because when you use this in theory, you will lose marks. Okay, now the second one, so divide the x, just like we did with the first question. You keep the first function, which is 2x minus 1, so equal to 2x minus 1. Then we differentiate the second function, and then when you differentiate this, you'll be obtaining 3. Use that 3 to multiply the first function that you've kept here. So plus, so here you keep the second function, which is 3x plus 2. All right, then you differentiate what? The first function, you will obtain what? Just 2. Okay, so now divide the x, expanding the bracket will be equal to here, we get what? 6x minus 3 plus 6x plus what? 4. Okay, so divide the x will be equal to 6x plus 6x, we have what? 12x. So minus 3 plus 4, we have what? Plus 1. So when you compare these two solutions with the first two examples that we did, you'll realize that we have what? Obtained the same results as we obtained when we use the formula to solve the differentiation. Okay, so this will be the end of the product rule of differentiation. Okay, so in my next video we will look at how to use the quotient rule to solve the differentiation. Okay, so don't forget to subscribe to my channel if you are new to this page, and most importantly, make sure you turn the notification button on so that when I upload new videos, you will be notified, and then you will follow to benefit your own self and then to benefit the community. And don't forget to share for the benefit of others. Have a nice day.